Hello, everybody. This is Dr. Jimmy Brown. A few weeks back, I made you a video about different qualitative research designs, and I wanted to make a quick one for you about different quantitative research designs. First thing I want to think about, though, is number one, when we think about quantitative research, is what is it? Quantitative research is different than qualitative in a couple of very important reasons. Number one, when we think about it, qualitative research looks at quantitative, looks at if and to what extent something's happening. We have testable hypotheses. We are looking at the relationship between variables. We are considering we're studying the effects of one thing on another, or the change of something over time as a result of something. And then we're also using statistics to determine the significance of the results. We're also very concerned, we'll talk about a bit about generalizability and validity and things like that. Whereas in qualitative, as we talked about last time, we are focused on how and what and why about a phenomenon. We're concerned about, we don't have hypotheses there. We don't have things about, they're usually the individual group experience. Here, we're not worried about what one individual thinks or feels. We're worried about, is the whole group happening? And we'll talk about with statistics, is it happening more than we expect by chance alone, which is a very critical point. So before we get into this, I want to talk about variables, because variables are a key component of quantitative analysis and statistics. And so variables basically some characteristic of a person, a group, or an organization that we can quantify. The example I always use is things like, for a person, will eating too much fast food make us gain weight? Or with a group, will trying out some new program cause people to perform better? Those are quantifiable things that we can measure. And, we can debate later about the whole issue of, the social constructionism of quantification, but for now, we're going to assume that quantification is relatively objective, and we're going to assume that it's measurable is something we want to look at. Now, there's a couple different kinds of variables that we're concerned with. First, there's independent and dependent variables. Now, an independent variable is a standalone variable that does not change. So it's the thing that acts on something. So again, the example I always use is fast food and weight and BMI, right? So we can say the number of days we eat fast food a week would be an independent variable. That's what we're measuring to see if there's an output. And usually when we're testing it, we're looking at some change in that or comparing some groups of it. A dependent variable is a thing that changes as a result of the independent variable. So for example, our fast food example, we can go to the number of days of food we eat fast food per week. The BMI is something we can measure over time to see if that changed, or we can compare it by groups. It depends to or relates to or it's caused. Now, these are the two most common terms. Now, one thing I do want to point out, though, is in some sources, and this isn't universal, but you should be aware of them, there's what's called predictor and criterion variables. And some people see these as related primarily to correlations, but what they're saying is it's saying that a predictor is predicting the outcome of another variable. So example, using attendance to predict student course grades, right? When we talk about correlations here in a minute, this will become very important. A criterion variable would be something that changes as a result of the independent or predictor variable. This usage is not universal, but the folks who like to use these for correlations are very, very set on it. So just be aware of it. Now, when we're thinking about variables, we think about the validity of our research. So there's really three main ways of determining validity. And some people also use this to determine minimum insights for a study. The first one is sampling error estimate, which what this is saying is this is the number of people that we have to have in our sample to be confident that our sample's responses are not markedly different than the population they represent. So for example, let's say if we asked 10 people let's say we have 10 people, and we asked 5 of them what their favorite flavor of ice cream was. Well, we could not be real confident that they were representative of the other 5, because just statistically, non-response bias, things like that, they could be very different. If, however, we had 10 million people and we asked 5 million of those, the chances of them being different would be very small. So there's a weird thing here where the larger the population you have, the smaller the percentage population you have to talk to get a representative sample, but you should be aware that that is one way to do it. Another way to determine validity, and also minimum sample size, is what's called statistical power. And the fancy way of saying this is the probability of rejecting a null hypothesis when the alternative is true, i.e. the probability of avoiding a type 2 error. This one's really important. A lot of universities use this to calculate minimum sample size for dissertation studies. There's debate as to whether that's the right way to go. You would always want to do one a priori and post hoc, i.e. before the study and after the study. What you're looking at there is how likely is it that you're measuring a real effect, which we'll talk about that in just a second. There's a tool out there called G-Power that is basically, it's the go-to for that. You can Google it, download it. You can tell it what kind of data you have, what statistical test you're running. It will tell you the minimum sample size to have appropriate statistical power. I'm not going to get into detail on how to do these here. There's like a whole other set of videos, but just be aware these exist. And when you're talking to people about how to do research, like if you're a student, want to figure out how much your minimum sample size is for your study, you should probably talk to your chair in your school about which one of these they want you to use. And there's a third one that's typically not used in university research. It's called effect size. And what effect size is doing, this goes back to our correlation criterion predictor variables a minute ago, is measuring the strength of the relationship. So for example, let's say we do a relationship between, if we were looking at our relationship between the number of days one works out a week and heart health. Those are two things we can measure very clearly based upon some particular measures. If we would need to figure out the number of people we would need to have a strong effect size versus a weak effect size. And again, there's a lot of statistical things to do in that. I'll let you dig on those later. I'll make some videos later about that. But just know that sample error estimate, statistical power, and then also effect size are the three main ways of determining the validity of a study or the validity of your statistics. And most universities these days are using a statistical power, but just be aware those different three exist. So the other thing to think about is hypotheses. What is a hypothesis? A hypothesis is a predictive statement which basically says that we think X is going to impact Y. That's really all it is. And we use it based upon, typically you want to have some theoretical basis for it. So for example, if we're using, say, I don't know, systems theory to predict an organization's performance because they implement some new methodology that looks at a wide range of things. And that would be a theory we use to make a prediction for hypotheses. Now, again, as I mentioned a while ago, and if you see my video on statistics, we have a research question that says, does the number of days of eating fast food influence body mass index or BMI? Our null hypothesis would be the number of days per week that someone eats fast food, and then the fast food would be, the BMI would be the outcome we were predicting. So that is a null versus an alternative hypothesis that would relate here. So I got all that out of the way. What are the quantitative designs we're going to talk about? Well, the first one we're going to talk about is experimental. Then we're going to talk about quasi-experimental. And then we're going to talk about some of the non-experimental designs. Now, I want to be very clear that if you read 4 different texts about what the different non-experimental designs are, you're probably going to get 4 different answers. I went through Cresswell, about 4 or 5 other sources, and what I did here was try to coalesce them into something that's kind of consistent. But just be aware that aside from experimental, quasi-experimental, and non-experimental, there is not agreement in the literature on what the others are. People mix them up, mix and match them different ways, but I pulled the 4 most common ones here. Those 4 most common that we're going to talk about here are correlational, causal comparative, survey method, which I personally survey more as a data collection tool, but a lot of people put that as a design, so we'll talk about it. And then longitudinal, which will measure things over time. So let's talk about these here real quick. Experimental design is really where a researcher has full control over the environment, and they randomly assign subjects to a condition and then measure those conditions. In fact, some people say that in true experimental design, even the researcher does not know who's assigned to which condition. So these are a lot of your biological studies are done like this. In some experimental psychology do this, but for ethical reasons, you typically see these. Almost never see them in education because ethically, you really can't do one thing for one set of students and one thing for another. Without, you can't do those. But really, it requires the highest degree of rigor, requires the highest degree of controlled environment, And it's very, very rare to see some, like, say, business research, psychology research, or education. You see it more in things like chemistry, physics, some in biology, different things like that. A little bit in medical research, although with medical, there's some ethical reasons why sometimes you can't do it. But this is where you have the most control. When people think of research, lab coats, controlled circumstances, this is what they're talking about. Another one we'll talk about here is quasi-experimental. Now, this is still looking at cause and effect, just like the experimental is, but the researcher doesn't have full control. Case in point, when I was in college, my freshman year of college, my freshman psychology course, we had to go participate in at least 2 experiments to pass that course. One of the experiments, they put us in a room and they, gave us these little, one person got a red disc, one person got a blue disc. And the whole experiment kind of went that way. It kind of went awry because I had just read about something like this and I was aware of what they were doing and it kind of, threw it off. They couldn't control that I had that external stimuli, external environment to impact me. A lot of research in psychology is quasi-experimental. Say if you want to, the Milgram experiments, they were where basically, if you haven't seen those, Google them. They didn't know who had been in high authoritarian situations versus who hadn't, and so that impacted a lot. There's not full control. There may or may not be random assignment. You try to have as much rigor as possible, but it's more of a real. It's more realistic because you can't control everything. You can't, and often the researcher knows who's in which conditions and who's in which conditions. So sometimes the researcher's bias and the researcher's actions can influence it. So there's some question here about, are there other factors? For example, my prior knowledge and that thing I did in college would be a difference there. A non-experimental studies, we'll talk about in a second, we'll talk about here in just a second, is an attempt to really look at some data. It can be originally collected data, it can be archival data, but it's usually done more in a natural setting. So what are these? The first one we'll talk about is a correlational design. And again, this is where we say X influences Y. The number of days I eat fast food influencing my BMI. That is a pure correlational study. We have two measure interval variables that we can measure, and we're saying one versus the other. And what we're doing here is we're going to look at that and say, okay, let's say we find a 0.70 correlation. Well, is that statistically significant? And what we would then do is we would correlate, we would do some analysis to figure out if we would see that kind of correlation by chance alone. And again, the statistics video, if our measure would be, say, if we only saw it, would see that by chance alone, say 5% of the time, they would think, yeah, there's probably a real effect. Now, one thing we have to remember though is correlation does not cause causality. Does not necessarily mean causality. We think it might be, but we can't confirm it outside of a fully experimental setting. It's like the old thing about, there's a correlation between ice cream sales and the murder rate. Well, yeah, there is, because both of those go up in the summertime when it's hotter. So the variables, usually this is used when variables cannot or should not be manipulated. So for example, if we're looking at hours of sleep for children and their GPA, well, you cannot and should not manipulate children's hours of sleep. But what you can do is say to their parents, hey, will you be sure to record how many hours of sleep your child gets? We'll record it over time, look at the GPA, see how that works. So this is usually when you have something you want to really do some real measurement to, but you can't ethically do this. We can use survey data, we can use archival data, different things like that. Now, a causal comparative is when we have two groups and we're measuring on something and we're assuming that the difference between those causes that outcome. Okay, so case in point, I had a student a while back that I chaired her dissertation, and she was looking at how pay for performance impacted the student, pay performance for teachers impacted student performance. And this is another one where she used archival data, and what she did was she found two groups who were very similar. She was in Florida. She found two school districts that had very similar demographics as far as Title I, SES levels, racial demographics. They're actually fairly closely to each other geographically, so fairly close together, but one paid for performance for teachers, the other did not. And they looked at the student outcomes based upon some standardized tests they did over the course of like 5 years. Pulled the archival data, run the statistics. Interestingly, the school that did not pay performance had slightly higher results than the school that didn't, but they did pay for performance, but those results were not statistically significant. So we actually retained her null hypothesis that they just don't really affect it. And we're looking at that comparison between those two. And this is very common in education research, again, because in education, manipulating children, whole lot of ethical issues there, but you want to compare, if you want to compare things, you'll find two equivalent groups. And you'll often see some students, a lot of research, things like inclusive classrooms for children with disabilities, or we'll look at with Title I schools, different kinds of education they're using, some of the things they do with charter schools. All those different kinds of comparisons there are very common. We'll see this sometimes in, like, say, IO psychology. If you have a company, you have two different parts of the organization, one tries something, the other does not. That would be a causal comparative design if you compared those two. So the next one, we'll talk about survey research. Survey research is looking at the opinions of the group. Again, personally, I see this more as a data collection approach than a design. The one reason I include it is if you go to Cresswell and a lot of other sources, they actually include it as a design, but so I included it here. This is the one where it's very important to make sure you have things like sampling error and non-response bias be very, very important. We see this with, like, say, if we're doing like a survey of wanting to figure out market research, right? We're wanting to do an experiment and figure out, does some new flavor work for some company in a location? Well, you would start having one location, not having another. Everybody remembers the whole new Coke thing, right? They went and did some surveys where they said, hey, drink this new Coke, send a survey back what you think about it, right? And they had a very small sample, so they liked it. Unfortunately, that was not representative of the whole US population, and the whole thing just bombed. And I'm sure, if you watch news enough, you can see where surveys for different things that the public likes don't really predict the outcome. This is why it's very important. And also, when we talk about hypothesis testing, you may have a hypothesis that group A is different than group B. Survey shows different opinion. The question becomes, do we really know that or not? Now, the last one we'll look at here is longitudinal research. And this is, again, personally, I would say that I'm not sure if there's debate if this is a true design by itself or not. We'll go ahead and go with it for here. For longitudinal research, it's really looking at research over time. And the picture I have here shows what's supposed to show a woman who's grown over generations. For a lot of longitudinal research, one of the biggest challenges is finding a big enough population sample to be able to see, to count for dropout. There's been research, like there's one study we're looking at, how successful kids are, and they started studying these kids in the 50s, and they're still tracking them today. But obviously over time, a lot of folks drop out, disappear, things like that. And one of the big challenges is it's basically take a long time to do. In fact, if you're doing a doctoral dissertation, if you ever work with me, I tell you no longitudinal research. If you can find some archival data that already exists that you can analyze in a new way, sure, but just, it doesn't make sense to collect that data, because if you're a dissertation, you want to graduate. But this is really, and you can do this as correlational or causal comparative. You can do all kinds of different things with it. And these are, again, the different designs. Now, again, you can use different statistics, like, say, a t-test or, a regression analysis, chi-squared, depending on the kind of data you have. And we'll make some videos about that later. But these are different kinds of approaches you could use in the course of these. So that's about it. I hope you got value out of that. And if you have any questions, please don't forget to like and subscribe below. If you have questions, leave them in the comments. I'll be happy to try to answer them. And I will also leave in the comments links to the books we have here on our, these are some of the sources I used. I'll use links to those in the description. And please don't forget to like and subscribe. Hope all is well. See you soon.